Hello everyone. Today I will illustrate how to set up explicit messaging in Ethernet IP using SIP function blocks to gather data from CJ2M-CPU33 and NX1P2 PLC to any machine automation controller NJ or NX series PLC. I am Trinh, Senior Application Engineer for Valin Corporation. Let's get started. So here's my layout for the example I'm going to go through today. I have the machine automation controller NJ501-1300 with Ethernet IP 192.168.250.3. And this PLC is basically will collect the data from the CJ2M-CPU33 PLC with the IP address from 192.168.250.5 and another NX1P2 PLC with an IP address of 192.168.250.1. And I have all these three PLC connected to a Ethernet switch, W4S1, and I'm using Omron Sysmac Studio software to set up these SIP function block. So first and foremost, here's the function block that you would need to set up. So right now I'm on my master PLC, which is NJ501-1300, and in there I'm using the function block called CIPUCMM Read. So to set up this function block, I have the root path, and in the root path, since I'm using the CPU port of the NJ, so the root path would be 02/192.168.250.5 because that's the CJ2M PLC IP address, and you want to have a /01/00. 1 means internal backplane port and 0 means CJ PLC. The timeout I set up as 10 seconds. If there's no response and it's timed out, the source data is, the tag name is from CJ_SIP_Note5, and that basically a tag name is actually a structure in the CJ2M PLC, and the size is basically one structure, and the destination data is from CJ-CIP_Note5. So this is the tag name in my NJ501. So let's take a look at that real quick, okay? So if I go to let me show you my CJ real quick. So if you look in the CJ here, in the symbol table, I have this from CJ_SIP_Note5, and that is matching what I have for source data. And in here, as you can see, the data type is the structure that I created or defined, and let's take a look at that. And the data type, so here's what I have, because if you look at the symbol, I have structure S from CJ read, and if I look over here, S from CJ read, the member inside the structure is employee with the data type integer, machine, another member machine with the data type integer, another member temperature _PV with the data type real, and another member pressure _PV with the data type real. Now if you look on my NJ side, within the structure from CJ to CIP Note5, I use structure from CJ read, and that is right here. And you look at this structure and this structure, they match. That is very important that these members and the data type are matching. Okay, so that's how you set up tag. Let's go back to this real quick. So to set it up, once again, you have the root path, the timeout, the source data, the size, and also destination. And that's all you have to do. To write the data from the NJ to the CJ2M, I use the CIPUCMM Read. And in this function block, you once again need to put in the root path. This is similar to what I have up here. Timeout, structure, the destination. This is the structure in the CJ. And in this example, I have 2CJ_SIP node 5. Again, this is the structure. And if I look at my CJ, under the symbol type, under the symbol, I have 2CJ_SIP node 5, which match exactly what I have on this side at the destination data. And then I only want to write one structure. That's why the size here is 1. And the source data is coming from my tag name called 2CJ_CIP node 5. And again, if I look at this structure, this is from the structure S2N PLC. So if I do look at this, so here it is, S2N PLC. And these are the members inside the structure. And if I bring back my CJ, you will see that it's matching. So here we go. The structure is 2N PLC. And when I look deeper, 2N PLC, you notice all the members here as well as the data type matching what we have over here. Okay, so that's how you set up the structure to be able to receive the data as well as sending the data. All right, let's get back to the program. So to read the data from the CJ, I'm using CIPUCMM Read function block. To write the data from the NJ to the CJ2M, I'm using CIPUCMM Write. So let's see how it works. So right now, I'm going to go online, which are already online, for my data from CJ_SIP_node 5. Temperature, I'm going to change this data a little bit, and then we'll see what happens. I'm going to have this as 55.53. For the pressure, I'm going to have 5.90. The machine number, this is coming from machine number 50. And the employee who's operating machine right now is 57. So that's the employee number. As soon as I click my UCMM_SIP read here, you will see the data coming to here. Here we go. There you go. So now you can see that the data coming from the CJ is matching exactly what you have on the NJ now. So that's how you read it. Now to write it, let me test it and show you how it works over here. So right now, let's say my machine number is, let me change this to so it's matching 57. Let's say I want to change the set point to 105.45. Pressure now it's going to be 7.8. So here's my CJ side. As soon as I execute this bit, the machine number, the temperature set point, and the pressure will be coming to the CJ right here. So right now they're all 0. I'm going to trigger it now. And if I go back here, so there's the data, 57 for the machine number, 105.45, which is the set point, and also the pressure will be 7.8, which matches exactly what I have here. So that's how you set up from NJ to CJ. You use the same function block for any NX machine automation controller, NX or NJ. So here I already created another 2 function block here. I also have the NX1P here on this side. So let's say on this side, I have to read the data from the NX1P. I created a structure NX102_SIP_DS_out. And that is, here. So I have the data right now is 111 for the integer. The real is, I'm going to change this to 1.23. A word is 1, 2, 3, 4. The bit is false for bit 0 and true for bit 1. As soon as I trigger this, the data from the NX1P2 will be coming into NJ3_SIP_DS_N, which is here. All right, so let me bring this back up, and I'm gonna execute this right now. Actually, let me change it to a different number because this is the old data that I have. So it's gonna be 2222. It's gonna be 4444.4, and this is 5678, and this is true, this is false for bit 0 and 1, and I'm gonna click this one now. All the data is coming over from the NX1P2. Let's take a look again to make sure whether it's matching. Yep, everything here is matching exactly what you have here. So that's how you read from the NX or NJ PLC. All right, so let's say I want to write some data over from my master here. So let's say, so here we go. Let me do this. So how do I write? I use the structure from my NJ, which is NJ3_SIP-DS-out, which is here. Okay, I'm going to write it to my NX1P2, and the tag name in the NX1P2 is NX102_CIP_DS_N. So here's the data that you will see as soon as I execute the write bit here. But before I do that, these are some old data. As you can see, it's already matching, but I'm going to change it to a different number. So this will be 66 for the integer. The real _1, I'm going to make it 100.9. The word is FFFF. Remember, this is word, so it can be hexadecimal. I'm going to change this to false for bit 0 and true for bit 1. Now I'm going to execute this. Actually, I need to turn this one off first. Now I'm going to turn it on. I have a look on my NX1P2, and here's the data. It's matching exactly what I wrote from my NJ501-1300. So that's how you set it up to collect the data as well as writing the data between the machine automation controller NJ or NX PLC to CJ series PLC as well as another NX or NJ PLC. If you have any questions, please call the number below, and thank you for watching.